Could hydrogen be the key to a clean energy future? This question is sparking curiosity and intrigue across the globe. Hydrogen, the most abundant element in the universe, is stepping into the spotlight as a potential superstar of sustainable energy. Imagine a world where our cars, homes, and industries are powered not by fossil fuels that pollute our planet, but by this clean, renewable energy source. The applications of hydrogen energy are as vast as they are promising. From fuel cells that generate electricity to hydrogen-powered vehicles that emit nothing but water, this versatile element is showing us a glimpse of a greener, cleaner future. But, as with any frontier of scientific exploration, there are challenges to overcome and opportunities to seize. The quest for hydrogen energy is more than a scientific endeavor. It's a journey of innovation, environmental stewardship, and technological advancement. Intrigued yet? Let's dive deeper into the world of hydrogen energy. Before we delve deeper into the science of hydrogen, let's take a step back and see how this miraculous element is found in nature. As we've mentioned, hydrogen is the lightest and most abundant element in the universe. But did you know that every drop of water contains hydrogen? That's right, 2 parts hydrogen and 1 part oxygen make up the H2O we drink every day. Hydrogen is also found in vast quantities in organic compounds, especially hydrocarbons, which form the basis of our current fossil fuels. Life on Earth is fundamentally tied to hydrogen. Without it, there would be no water, no carbohydrates, no life as we know it. Now that we've seen where hydrogen comes from, let's explore how we can harness its potential as a fuel for our future. First, we need to understand what hydrogen is and why it's being considered as a fuel source. Hydrogen, the first and lightest element on the periodic table, is the most abundant element in the universe. It's a colorless, odorless gas that doesn't exist naturally on Earth in its elemental form. Instead, it's found combined with other elements, like oxygen in water or carbon in natural gas. But why hydrogen? Well, it packs a powerful punch. With an energy content of about 141,000 BTUs per kilogram, it carries nearly 3 times more energy per unit weight than petroleum. Now that's what I call high energy. Hydrogen is produced primarily through a process known as steam methane reforming. This involves reacting methane with high-temperature steam to produce hydrogen, carbon monoxide, and a small amount of carbon dioxide. While this is the most common method of production, it's not the only one. There's also electrolysis, where an electrical current is passed through water to separate the hydrogen and oxygen atoms. The great thing about this method is that it can be powered using renewable energy, making it a potentially clean and sustainable option. Once we have our hydrogen, it can be used in a fuel cell to generate electricity. Picture this: hydrogen and oxygen are input into the fuel cell. A catalyst causes the hydrogen to split into protons and electrons. The electrons create a current that can be used to power electric motors, while the protons combine with oxygen to produce water. That's right, the only byproduct of this process is water. Hydrogen fuel cells are marvelously versatile, with potential applications ranging from powering our homes to fueling our cars. They're efficient, they're quiet, and they're clean. So the science seems promising. But how is hydrogen fuel being used today? Before we can put hydrogen to use as a power source, we need to extract it. As we mentioned earlier, hydrogen doesn't naturally exist in its elemental form on Earth. Instead, it's found combined with other elements, like oxygen in water or carbon in natural gas. But how exactly do we extract it? The most common method of hydrogen extraction is steam methane reforming. This process involves reacting methane with high-temperature steam to produce hydrogen, carbon monoxide, and a small amount of carbon dioxide. However, this method isn't perfect. It requires a lot of energy and produces carbon emissions, which contribute to climate change. But there's another method: electrolysis. Remember when we talked about passing an electrical current through water to separate the hydrogen and oxygen atoms? That's electrolysis. It's a clean method of hydrogen extraction, as it doesn't produce any greenhouse gases. However, it's also more energy-intensive than steam methane reforming. The energy used in electrolysis can come from renewable sources like wind or solar power, but these aren't always available. So we have our hydrogen, but now what? With hydrogen extracted, it's time to put it to use. Whether it's used in a fuel cell to power a car or to generate electricity for a home, hydrogen holds a lot of potential. But as with any new technology, there are challenges to overcome. In the next scene, we'll explore how hydrogen is being used today and what hurdles we need to overcome to realize a hydrogen-powered future. Stay tuned. Hydrogen fuel isn't just a concept, it's in use today. Let's delve into a few instances where hydrogen is not just making waves, but actual power. One of the most visible applications of hydrogen fuel cells is in the transportation sector. Cars like the Toyota Mirai and the Hyundai Nexo are already cruising our highways, powered entirely by hydrogen. These vehicles convert hydrogen and oxygen into electricity, with water vapor being the only emission. It's a clean and efficient process, but it's not without its challenges. Hydrogen fueling stations are still few and far between, making long-distance travel a bit of a puzzle. But it's not just cars that are going green. Buses, trucks, and even trains are starting to use hydrogen fuel cells. For instance, Germany has introduced the world's first hydrogen-powered train, the Coradia Island. Using hydrogen fuel cells, this train emits only water and steam, making it a clean alternative to diesel-powered locomotives. Beyond transportation, hydrogen is proving its worth in power generation. In places like California, hydrogen fuel cells are being used to provide electricity during peak demand periods. They're reliable, efficient, and most importantly, they're clean. They produce power without harmful emissions, making them an attractive option for grid operators. Hydrogen can also play a vital role in renewable energy storage. When the sun doesn't shine or the wind doesn't blow, hydrogen can step in. Excess renewable energy can be used to produce hydrogen through electrolysis. This hydrogen can then be stored and used later to generate electricity through a fuel cell when needed, providing a clean and reliable power source. But despite these promising applications, hydrogen isn't without its drawbacks. It's currently more expensive to produce than traditional fuels, and storing it can be challenging due to its low energy density. Plus, while it's abundant in the universe, it's not readily available on Earth. It has to be extracted from water or natural gas, which can be energy intensive. Clearly, hydrogen has potential. But what hurdles must we overcome to realize a hydrogen-powered future? Those are the questions we'll tackle as we continue to explore the world of hydrogen energy. Storing hydrogen is a challenge due to its low density, but we can't overlook its importance in the hydrogen energy puzzle. Let's take a closer look at how we can store this fuel of the future. There are 3 potential ways to store hydrogen. It can be stored as a gas, as a liquid, or in a chemical compound. Each method has its pros and cons. When stored as a gas, hydrogen is compressed at high pressures. This requires sturdy and expensive tanks, but it's currently the most common method. When stored as a liquid, hydrogen must be cooled to extremely low temperatures, which requires a lot of energy. However, liquid hydrogen takes up less space than its gaseous counterpart, making it a more efficient storage method. Finally, hydrogen can be stored in a chemical compound, such as metal hydrides or chemical hydrogen carriers. These methods are still in the research and development phase, but they promise significant improvements in terms of safety and energy density. Despite the challenges, hydrogen storage is a crucial piece of the puzzle. It's the key to unlocking hydrogen's potential as a clean, efficient, and reliable energy source. The challenges we face in storing hydrogen are significant, but so too are the opportunities for innovation and advancement. With continued research and development, we could soon see breakthroughs that make hydrogen storage safer, more efficient, and more affordable than ever before. The road to a hydrogen future isn't without its bumps. Indeed, there are substantial challenges to overcome in the quest to make hydrogen the fuel of the future. One of the most pressing issues is scaling up hydrogen production. Currently, we don't produce enough hydrogen to meet potential demand. This isn't because we're short on the raw materials. Hydrogen is the most abundant element in the universe. Rather, it's the processes we use to extract hydrogen that are the problem. They're energy-intensive, expensive, and often rely on fossil fuels, which defeats the purpose of a clean energy source. Another hurdle is infrastructure. We need a vast network of pipelines, storage facilities, and fueling stations to distribute and dispense hydrogen. Building this from scratch is a daunting task. Plus, there's the question of safety. Hydrogen is highly flammable, so we need to ensure that it can be stored and transported without risk. But every cloud has a silver lining. These challenges present opportunities for technological advancements and policy interventions. On the technology front, researchers are already working on more efficient and environmentally friendly methods of hydrogen production. For instance, using renewable energy sources like wind or solar power to split water into hydrogen and oxygen, an approach known as electrolysis. Policy-wise, governments play a crucial role. They can incentivize hydrogen production and use through subsidies, tax breaks, and regulations. They can also invest directly in infrastructure and research and development. Some countries like Japan and Germany are already leading the way in this regard. Moreover, the transition to a hydrogen economy could have significant economic benefits. It could create jobs in manufacturing, installation, maintenance, and other sectors. And it could lead to energy independence for countries that currently rely heavily on imported fossil fuels. The challenges are significant, but so are the opportunities. So, where does this leave us? Before we delve into the bright future of hydrogen energy, it's important to address an essential aspect: safety. Hydrogen, like any other fuel, carries risks. It's a highly flammable gas that can cause explosions under certain conditions. But don't let this scare you away, because with the right safety measures in place, hydrogen can be as safe as any other energy source. Hydrogen is lighter than air, so in the event of a leak, it rises and disperses quickly, reducing the chances of an explosion. However, this doesn't mean we can be complacent. Safety protocols must be strictly adhered to when handling and storing hydrogen. This includes using leak detection systems, proper ventilation, and specially designed storage tanks. Furthermore, training is vital. Those working with hydrogen need to understand its properties and how to handle it safely. This includes emergency response teams who may be called upon to deal with accidents. Increasing safety isn't just about preventing accidents. It's also about building public confidence in hydrogen technology. People need to feel safe using hydrogen-powered vehicles and appliances in their everyday lives. In conclusion, while hydrogen's flammability presents challenges, they are not insurmountable. With the right safety measures, protocols, and training, we can harness the full potential of hydrogen while ensuring the safety of all. Now that we've covered the safety aspect, let's proceed to explore the exciting possibilities of a future dominated by hydrogen energy. The potential of hydrogen energy is immense, but realizing it will require concerted effort. As we peer into the future, envision a world powered by this abundant resource. Imagine a planet where carbon emissions are a thing of the past, where every vehicle hums along on hydrogen fuel cells, and where our homes and factories are powered by the most abundant element in the universe. The future of hydrogen energy is promising. Researchers around the globe are tirelessly working to overcome the current challenges. They are developing innovative solutions for efficient hydrogen production, safe storage, and effective distribution. Projects like artificial photosynthesis and nanotechnology are under exploration, which could potentially revolutionize the way we harness hydrogen. The next few decades could witness the rise of hydrogen cities. These futuristic urban landscapes would rely entirely on hydrogen for their energy needs. From public transportation to heating and electricity, everything could be powered by hydrogen. Hydrogen could also play a significant role in the decarbonization of industries like steel and chemical production, which are traditionally hard to decarbonize. The prospect of hydrogen-powered transportation is particularly exciting. We could see fleets of hydrogen-powered cars, buses, and even airplanes taking to the skies. This isn't just a pipe dream. Several automakers are already developing hydrogen fuel cell vehicles, and some countries are investing heavily in hydrogen-powered public transportation. But a hydrogen-powered future isn't just about grand visions and cutting-edge technology. It's also about creating a sustainable, clean energy ecosystem that benefits everyone. It's about ensuring energy security and economic stability while protecting the planet for future generations. The future of hydrogen energy depends on our collective will to adopt and invest in it. It requires governments, businesses, and individuals to recognize its potential and make the necessary changes. Hydrogen energy could be a game changer. But it's up to us to unlock its potential. As we stand on the brink of an energy revolution, let's embrace the possibilities of hydrogen and work together to create a cleaner, greener future. Imagine a world where energy is abundant, clean, and renewable. This is the vision behind the concept of the hydrogen economy, a proposed system of delivering energy using hydrogen. The idea is simple yet profound. Use hydrogen, the most abundant element in the universe, as a low-carbon energy source to power our world. The potential implications are immense. Hydrogen could replace fossil fuels in all sectors of the economy, from transportation to industry to residential heating and electricity. This would not only drastically reduce our carbon footprint, but also help address energy security concerns. In a hydrogen economy, energy would be stored and transported as hydrogen, rather than as electricity or fossil fuels. This could lead to a more efficient and resilient energy system. Imagine hydrogen-powered cars that only emit water, factories that run on clean hydrogen energy, homes heated by hydrogen fuel cells. It's a captivating vision, isn't it? But like any vision, it comes with challenges. The technology to make this a reality is still in development, and we need to ensure it's safe, efficient, and affordable. However, with the right investment in research and infrastructure, the hydrogen economy could be the key to a sustainable future. It's an exciting prospect, and one that could transform the way we think about and use energy. As we stand on the threshold of this potential energy revolution, the question isn't if, but when the hydrogen economy will become a reality. The future is promising, and it's powered by hydrogen. We've journeyed through the world of hydrogen energy, and it's clear that the possibilities are exciting. We've learned that hydrogen, the most abundant element in the universe, has the potential to revolutionize the way we produce and consume energy. This powerful element offers a clean, renewable fuel option, powering everything from cars to entire cities, with water as the only emission. However, it's not without challenges. Harnessing hydrogen energy efficiently and safely requires advanced technology and substantial investment. Yet, the potential rewards are immense, not only in terms of energy sustainability, but also for our environment. The future of hydrogen energy is still unfolding, and it's a fascinating story to watch. Continued research and development are key to unlocking the full potential of this abundant element. If you found this deep dive into hydrogen energy fascinating, don't forget to subscribe to Brainiacata. Share this video with others to spread the word about the potential of hydrogen energy. Until next time, keep exploring and stay curious.